or x equals 5.
Okay. Now, what if, let's just say this was a 10-point question. I'd only give you 5 out of 10 points for this one. Why do you think that is? And it's not showing work. There's no
Without
work.
showing work.
It's not work related. Do you remember what the graph of x squared looks like?
It's like that, and then
And then 25, how many times does it hit the graph?
How many times does 25 hit the graph?
Yeah, if this horizontal line represents 25, how many times does it hit the graph?
Twice.
Twice. So there are 2 solutions.
Oh, so I have a case 1 and case 2, or
Yes, exactly. Basically, I was looking for 5 and -5.
Got it.
Okay. So in all the problems, when you're solving a quadratic, there are 2 solutions every single time. Okay. So that's something to keep in mind. Like, you can't give me one answer. There's always going to be 2. We'll talk about some different situations here. Okay, so let's talk about another problem. Let's say it was something like 2x squared minus 8 equals 0, and I asked you to solve this. Can you tell me what you might do first to solve something like this?
First I need to solve for. I need to.
It's okay if you don't know. These are just
No,
questions.
I have to factor this.
Okay, this could be factored. I agree. This could be factored. Let's assume you didn't want to factor this.
Then I need to distribute, or I need to equal out both sides. So I try to add 8.
Exactly. Yeah. So what I was going to ask, or what I was going to show you, is if this was like 2x minus 8 equals 0, what would you do? And you're exactly right. You would add 8 to both sides. So let's do that. We'll add 8 to both sides. Very good. 2x squared equals 8. Now what would you do?
Now I'll try to divide by. Well, now I'll divide by 2.
Good.
Yeah.
Very good. So x squared equals 4. Can you tell me the solution from here, please?
X squared equals 4. So x equals 2 comma -2.
Very good. Okay. Very good. All right. I'm just looking for another problem here for us to work on in just a moment. Okay. So here's one for you to try on your own, please. Let's have you try 3x squared minus 48 equals 0. You could solve this for me, please.
3x squared minus 48 equals 0. So first thing is add 48.
Yep. Go ahead and work this out on your own and just let me know what you come up with.
Is this one x equals 8 comma -8?
Okay, give me a little more information. That is not the correct answer, but let's just see what you did. Did you add 48 to both sides?
Yeah, I added 48 to both sides.
Okay, so that's 3x squared equals 48. Did you divide by 3?
Yeah.
Okay, did you
And
get
then I got 16.
Yes. Okay, so this is correct from here.
Oh, it's 4. It's 4. It's 4.
Yes.
Yeah, shoot. Okay. Yeah.
Well, that's only part of it. 4 and
-4.
-4. Good. Okay. So there's a list of like all the squares and square roots that you're supposed to know. Like, you're supposed to know 1 squared is 1, 2 squared is 4, 3 squared is 9. How far up do you feel like you might know in terms of this list without using a calculator?
4 is 16, 5, maybe up to 12, because
Okay, that's good.
yeah, I could try to do.
So the idea here is the more you know this list, the easier this becomes, the familiarity of it. Now, are you typically allowed to use a calculator in the classroom?
No, we don't use a calculator.
Okay, so this would be something to consider looking at, you know, and remembering, but no big deal for today. Okay, let's look at a new problem. Let's say I ask you to solve something like the following: x minus 1 squared plus 3 equals 28. Okay, what might you do first here to solve this?
Okay, so I see I'm gonna make two parenthesis signs and do x minus 1 and then another x minus 1 because this is being squared.
Okay, so that the one of the things that you, so that would work. It would work. It's not wrong. It's like you're taking the long way to get there. Okay, and there's only one x in this problem. If you look back at all the problems we've done today, one x, there's just a single x.
Right.
There's just a single x. When there is just a single x, and this is your identification, this is like, let's just say I gave you 5 problems and one was using the square root property. The one that has a single x, you're using the square root property. So this one you would actually subtract 3 from both sides. Okay, and the reason is you want to isolate the x minus 1 squared because you can undo the square with a square root.
Right.
Does that make sense?
Mm-hmm.
Okay, so if you take the square root of both sides now, this is that case 1, case 2. So this is x minus 1 equals plus or minus 5. And then from here, it's case 1, case 2. There's 2 equations. You want to write both of them.
And one is going to be positive and one will be negative.
In this example, yes, but not always. You know, math is full of exceptions. You want to be careful with those. You know, those are generalities.
Right.
It's like, you know, first pitch he always throws a fastball, and then all of a sudden, you know, there's a changeup at you, and you're like,
Right,
oh,
yeah.
what kind of silly.
Okay.
So you want to be careful there
Right.
when that happens. So you're going to add 1 to both sides, add 1 to both sides. X equals 6, x equals minus 4.
Got
Right.
it.
So that's your case 1, case 2. So if there's just a single x, like I gave you in this problem, that's when you want to use the square root property. So let me throw another one at you here. Let's go x minus 2 squared plus 4 equals 40. Go ahead and step me through this. Tell me what you would do first to solve this, please.
Okay, so I'll subtract 4.
Good. So
and I'll get 36.
Okay.
And then I need to do square root. So on the left-hand side, and then 6.
What's on the right side?
On the right side will be 6.
Plus or minus 6. Plus or minus 6. Very,
Okay,
very
plus or
important there.
Okay.
Yeah, they're both correct, and it's easy to forget one or leave one out. So now this is the case 1, case 2, right? X minus 2 equals 6. X minus 2
minus negative 6. Got it.
Okay, and then you would add 2 to both sides. X equals 8. Add 2, add 2, x equals minus 4. And that's your answer.
And then I have a question.
Yeah, go for it.
So just one, on tests and quizzes, he oftentimes gives us like a graph.
Yes.
And then from that point, I'm using these 2 points that I'm getting in the case 1 and case 2, and I'm putting them on the graph, right?
Probably. I mean, if this were asking you to graph it, I'm just going back in time. I mean, you've already learned this, so you're beyond that. But yeah, these are the x-intercepts. These are where it crosses the x-axis.
Got it.
You know, we'll call that minus 4, and then we'll call that 8. And yes, I'm just focusing on solving today with you. But yes, a good question. All right, now I would like you to do one on your own. So do you have any questions about anything we did? All I'm going to do is change the numbers. I'm not going to change the process. Just want to see.
Yeah, I'll try one of my own.
Okay. All right, so let's say it's x plus 1 squared minus 2 equals 14.
14.
Go ahead and try this one. And I just want your final answers. Assume I'm just going to grade what's in the box here whenever you're done.
All right, I have it.
Okay, what is your final answer?
X equals 3, X equals -5.
Okay, and how confident are you in your answers here?
I feel pretty confident about them.
Okay, so let's take a look here. We're going to add 2 to both sides. So we got x plus 1 squared equals 16. Okay, you're going to take a square root of both sides. X
Mhm.
plus 1 squared equals plus or minus square root of 16. So this becomes x plus 1 equals plus or minus 4. So your two equations would be x plus 1 equals 4, x plus 1 equals -4. How are
Okay.
we doing? How am I doing compared to what you have?
We have the exact same thing so far.
Okay, that's good. So you're going to subtract 1 from both sides. So x equals 3 and x equals -5. Any questions on that?
No, yeah, that's all. I got that part.
Great. Okay, so what is the solution to x squared equals -4? If you know, you may not know, but I'm just asking if you do.
Isn't there no solution or like?
That's
'Cause
right.
it's
That's
negative.
right.
It's a negative.
That's right. So here's what I just said. I said you have to square a number to get a negative number. And you can think real hard about that. Well, if they're both positive, because they got to be the same, that leads you to a positive. If they're both negative, that leads you to a positive. So this has no solution. Now, graphically, here's what this is graphically, because I think that is important to talk about and discuss, a lot is here's the graph, and then here's -4. Do these ever intersect?
No.
No. So there's no solution. Good. So here's a possibility. So if you ever see something like this in a test or quiz, possibility 1 is that it literally is no solution. The other possibility is maybe you've made a mistake. Okay, so that's why you want to double check your work. Now, sometimes problems have the appearance of having no solution, but they actually do have a solution. So let's look at this. Let's say it's I don't know, +8 equals 0. So -2 times x plus 2 squared plus 8 equals 0. If you subtract 8 from both sides here, you might start to think, well, maybe this does not have a solution because it equals a negative number. But what about this -2 out in front? How do you undo that -2?
In that case,
Yes.
would you distribute that -2 into the parentheses or no?
So order of operations says you have to do exponents first. So it's
All right.
stuck on the outside until
Okay.
you square it. So what is the math operation? What does this dot mean?
Multiplication, or what does that
Yes.
little dot mean? Yeah,
Yes.
multiplication.
So you undo that with
Division.
division. So we have x plus 2 squared equals 4, and now it's okay.
Right.
Now it works out. So you can't make a quick judgment until you're at the place where you know whether it does or does not work. All right.
Got it.
So could you go ahead and solve the problem from here, please?
Yeah. All right, I have my answer.
Okay. What is your answer or answers?
X equals 1, X equals -4.
Okay, so the -4 is good. The 1 is not. Now here's how I'm doing that. 1 plus 2 squared is 3. 3 squared is 9. Okay, so there's a small little issue there. Let's take a look here. So it's x plus 2 equals plus or minus the square root of 4, or plus or minus 2. Is that what you have?
Yeah.
And then you write the two cases, x plus 2 equals 2, x plus 2 equals -2, subtract 2, subtract 2.
Should I
2
just
minus,
leave it at 0? Oh, okay.
yes,
All
yes,
right. Yeah.
yes.
All
You know,
right.
you had $2, you bought something for $2, you now have $0. The other one is correct.
So this might be a sort of complicated question to ask, but I feel like I've heard this from my math teacher. Isn't like, okay, so go back to the top of that equation where x plus 2. Yeah, right there. In front of the x, isn't there a 1?
Which x? This one here or
Yeah.
the one out there?
Yeah, right there.
You mean the one inside parentheses?
Yeah, inside
Yes,
it, yeah.
yes, yes.
Oh, okay. But when you're like subtracting an x equals 0, you just leave it at 0.
Yeah, so but here's what I think you're referring to. If I asked you what is 5x minus x, there's really a 1 in front of the x.
Right.
Okay, and you have to know that it's there, and this is really 4x. Okay, and there's actually a lot of other things going on, like you can always divide a number by 1. That's, that'll come up later in the course. It's always to a power of 1. There's always a 1 in front. And these are things that are they're known, but they're not written, or they're implied, if you will. Does that help? Does that answer your question?
Yeah. I was just confused about that one part, but I got it.
Okay, so let's try. So what if there's a negative out in front of something like this? Okay, so let's work through this one together.
Okay.
Let's say I ask you to solve this. What would you do first? What would you undo first if you know?
-6.
So we're going to subtract 6 from both sides. So we got negative parentheses x plus 1 squared equals -1. What is really out in front here? You kind of alluded to that earlier.
A 1.
Yeah, it's really -1. So I undo it by dividing by -1. So that becomes x plus 1 squared equals 1. Will you solve the problem from here for us, please?
Yeah. I have my answers.
Go ahead.
X equals 0, x equals -2.
Very good. They both work.
Right.
Right. Let's see here. So everything we've done today also applies to absolute value equations. And for some reason, they seem to introduce those at the same time, but in terms of the case 1, case 2. So that's related here. Let's try one more problem here together here, since we are running a little short on time here. So let's say I ask you to solve something like this: 25x squared equals 1. We're going to first undo this multiplication by 25. So we're going to divide both sides by 25. So x squared equals 1 over 25. Now, when you take the square root of both sides, it's always plus or minus square root of 1 over 25. And this is going to look really awkward from the beginning. Now, I think you've seen this in your class, not sure, but the square root of a over b is the square root of a over the square root of b. Basically, you can take the square root of the top and the bottom separately. So this would be the square root of 1 over the square root of 25. And this becomes 1 over 5 like that.
Yeah, this seems sort of familiar. The
Seems
A
sort of
over
familiar.
B. Yeah.
Yes. Okay. So you your answers aren't always nice. Okay. Another problem that we did not get to today is what if I ask you to take what if x squared equals 12, and now it's plus or minus the square root of 12, 12 is not a perfect square. And maybe you've seen this in class, but this ends up being 2 square root 3. Have you seen that in class, reducing roots?
We haven't seen where it's gone down like that. No, not yet.
Okay, so that may be coming, or we'll see.
Yeah.
It definitely part of quadratic formula and stuff like that. Okay, so we're gonna go ahead and stop right